So, in the last video, Chapter 4.1, we talked about the history of the atom and how it's evolved over time. In Chapter 4.2, we are going to talk about the structure of the atom as we accept it today. So, because of the work done by Dalton, Thomson, and Rutherford, we know that the atom is made up of small bits, and these small pieces are called subatomic particles. Sub meaning within, or smaller. So, literally, subatomic particles means particles smaller than the atom. And there are three main subatomic particles: the proton, the electron, and the neutron. We now know that each of these three things is then in turn made up of smaller bits. There are things like neutrinos and taus and all kinds of crazy tiny quantum particles, but in this class we're just going to talk about the three main pieces that make up the atom: the proton, electron, and neutron. So the proton, as you probably know, is a positively charged subatomic particle found in the nucleus of the atom. So the nucleus is this big centerpiece right here, and because it has a whole bunch of protons in it, it is overall positively charged. The number of protons in an atom defines which element the atom is, and this is super important. The only reason a hydrogen atom is different from a helium atom is because it has a different number of protons. It doesn't care how many electrons or how many neutrons it has. The number of protons defines the element. So you can see here the hydrogen atom has one proton, the helium atom has two protons, these little purple pieces, and the lithium atom has three protons. Now, yes, they also have different numbers of electrons and neutrons, but I could take these neutrons out or add a whole bunch in, and that would not change the fact that this is a lithium atom. The only thing that would change the fact that this is lithium is if I removed or added a proton, which is super hard to do. The electron is a negatively charged particle that's found in the space outside the nucleus. So remember in the last video I said that if we had a football stadium and we put a marble in the center, that marble would represent the nucleus. The electrons are negatively charged and they are found anywhere else in the stadium. They could be in the seats, they could be on the field, they could be up in the air above the stadium. They can be in any of those places at any time. And that's where they live. We can think of them as zooming around in there. They don't really zoom around. Electrons are very weird little things, and they behave very oddly. But they are found everywhere in the atom that the nucleus is not. And electrons are easily removed or added to an atom, and these determine the charge of the atom. So if I were to remove this electron, just take it right out of there, this element would not change. The number of protons in this nucleus are the same, so the type of element is the same. But because it has one less electron, that means the overall charge of this atom is going to be positive because I've removed a negative. And if you take a negative away, you're left with a positive. So electrons are what determine the charge of the atom, and we call these ions. We're going to talk about them later this year. A neutron is the neutral subatomic particle found in the nucleus. So the nucleus is made up of protons and it's made up of neutrons. And neutrons don't have a charge. They're totally neutral. They don't add positively or negatively. And the number of neutrons determines what variation of the element the atom is. This is kind of a really weird concept. But if I keep the number of protons in the nucleus the same, but add a whole bunch of neutrons, I am not changing the type of element this is, but I am changing how heavy it is. So it's going to act a little bit differently than one with a different number of neutrons. This is what we call, there we go, an isotope. So an isotope are atoms of the same element, meaning it has the same number of protons, but it has a different number of neutrons. So, this is hydrogen. A regular hydrogen atom has one proton in the nucleus and one electron on the outside. It has no neutrons in the center. Hydrogen 2 is how many particles there are in the center. Hydrogen 2 has that one proton, which makes it hydrogen, but we've added a neutron, and this makes it much heavier. Hydrogen 3 still has 1 proton, but we've added 2 neutrons, making it even heavier. And because we are adding neutrons, meaning we're adding mass, this will result in a different mass number. So, we can compare these 3 particles by looking at their mass, their charge, and their location. So, a proton has a charge of +1. It is always positive, and it has a mass of about 1 atomic mass unit. It's found in the nucleus, so if there is a positively charged, fairly heavy particle in the nucleus, we know it's a proton. A neutron doesn't have a charge at all. It is totally neutral. It also has a mass of about 1 atomic mass unit, meaning it's fairly heavy for a particle, and it's also found in the nucleus. So if we're comparing particles that are in a nucleus and fairly heavy, but one has a charge and one doesn't, the one with the positive charge is the proton, and the one without the charge is the neutron. An electron is totally different in every way. It has a negative charge, and it's really, really, really small. It has a mass of about 0.0005 atomic mass units, meaning it is much, 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 much smaller than a proton and a neutron. And it's found outside the nucleus in all of these spaces out here. So, looking at these 3 things, charge, mass, and location, we can determine what kind of particle we're looking at. Finally, the number of particles in an atom determines certain properties. So we know that the number of protons determines what element it is, and the number of electrons will determine the charge of that atom. Well, if we change the number of neutrons, we can also change something about it. So the atomic number of any element is the number of protons it has. And this is what determines the number an element is on the periodic table. So hydrogen is number 1, and that's because it has 1 proton. Helium is number 2 because it has 2 protons. And lithium is number 3 because it has 3 protons. So, the atomic number of hydrogen is 1. The atomic number of helium is 2. The atomic number of lithium is 3. And as we add protons, we increase in atomic number. Now, the mass number is the number of protons and neutrons put together. And this will tell you which variation of the element you have. Remember, that's called an isotope. So, if we take a look down here, let's erase our atomic number so that we can add some mass numbers. The atomic number for hydrogen was 1. The mass number is the protons plus the neutrons. So we have 1 proton, we have 0 neutrons, so the mass number for hydrogen is 1. It is exactly the same as the atomic number, but that is not always true. Let's try helium. Helium has 2 protons, and it has 2 neutrons, so the mass number for helium is 4. If I have a mass number for helium of 5, that means it has 2 protons, because helium always has 2 protons, but it has to have 3 neutrons in order to make it 5. Lithium, down here, has 3 protons and 3 neutrons, so it has a mass number of 6. If I have a mass number of 5, that means one of these neutrons is not here, because the number of protons always stays 3 in order for this to be lithium, but we can change the number of neutrons. So, that is our discussion of subatomic particles and what atoms are made of. And as we learn more about atoms, we will learn more specifics about why these particles are really important for certain elements, and especially how they are categorized in the periodic table.